Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 11A Part 2 assignment. First, I want to take a look at number 9. For each of the following curves, find the equation of the tangent at the given point and find the point at which the tangent meets the curve again. So, let's focus on part I here. Find the equation of the tangent at the given point. Okay. So that means take the derivative, right? So f prime of, well, let's back up. Let's see, there's three things that we need. We need the x value, we need the y value, and we need the m for y equals, nope, y minus y1 equals m times x minus x1, right? So we already know that our x1 is going to be -1. To find the y, let's just simply plug -1 into this function here. So 2 times -1 cubed minus 5 times -1 plus 1 is going to give us what our y is. -1 to the third power is still -1, so that's going to be 2 times -1 is -2. -5 times -1 is plus 5 plus 1. So that's going to give us y equals 4. Okay, and then to find the slope, we got to find the derivative, right? So y prime is 3 times 2 is 6x. Subtract 1 from that, that's 6x squared. And that's 5 is the first. 1 times -5 is -5. And then 1 minus 1 is 0. So the x's are gone, and the derivative of constant is 0. So there's our derivative function. Okay. So then we want to know what our slope is when x is -1. So we'll just do this. 6 times, plug in our -1. And off we go. So we get -1 squared is +1 times 6 is 6 minus 5. So our slope is going to be 1. So now that we have all those pieces there, we can simply plug it in to this over here. Y minus 4 equals m, which is 1 times x minus -1. So we get y minus 4 equals, distribute that 1 through, and that's still x plus 1. Add 4 to both sides, and we get y equals x plus 5 for the equation for part 1. Okay? Now for part 2, we want to find the point at which the tangent meets the curve again. Our best bet on that is just to enter that into our graphing calculator. So what we want to do is put the original equation in. We've got 2x to the third, right, minus 5x plus 1 for one equation. And then the second equation, we're going to actually just enter in our tangent function. So we're going to do x plus 5. And then, I'm not sure if we zoomed strangely or not. We're going to go to zoom standard. Push, enter, which is going to, or we're going to push graph. But okay, anyway, so it's going to graph these two equations. So the blue one is our original equation, and then this red one here is our tangent function. So good news, that looks like that's the tangent at when x is -1, which is what we want. And then all we have to do is find this intersection point. So to do that on our graphing calculator, second trace, which is calculate, and we want to find 5, the intersection. Okay, so we do intersection, and I'm just going to scroll this over. Right, and all I need to do is make it so that the intersection is closer to this point than that point. So that's pretty good. So first curve, yep. Second curve, yep. We want to find the intersection between those two curves closest to those points, and it's at 2, 7. So part 2 is going to be, it's going to run back into the curve at the point 2, 7. Okay? Okay, part C here, same idea. We need to know what x is, what y is, and what our slope is. So x we already know is 1.5. So to find y, we're going to plug that 1.5 in. So we get y equals 1.5 to the third plus 5. That's not a very nice one, is it? But we will make it work. Okay, so go back to our calculator piece here and do 1.5 to the third. Oops, I'm going to get rid of that. We got to go over. There we go, plus 5. And that tells us that's 8.375. Okay, so 8.375 is our y. Now we got to find the slope. So in order to find the slope, we want to find the derivative first. So f prime of x, 3 times 1 is 3. Subtract 1, and that's x squared. The derivative of constant is 0, so there's our derivative function. So then we plug our 1.5 here. We're going to plug 1.5 in for this x to figure out what our slope is, right? So f prime of x, which is 1.5, we can just still leave it right as f prime of x is fine. 3 times 1.5 squared, and that's going to give us, let's see, 3 times 1.5 squared. And that gives us 6.75 f prime of x, which really is our slope. So 6.75. Okay, so now we have all of our numbers. We're just going to plug it into our point slope formula there. So y minus y1, which is 8.375, equals m, which is 6.75 times x minus 1.5. And then away we go. So we get y minus 8.375, and then we distribute this 6.75 to both of those, right? So let's see, that's going to be 6.75x minus, so we got 6.75 times a 1.5. That gives us 10.125. Add 8.375 to both sides. And I think that's going to make this answer look a little nicer. Y equals, let's see, so we really have negative 10.125 minus, plus 8.375. And we get negative 1.75. Okay. So, that's what, I shouldn't have put that there. Negative 1.75, so we get 6.75x minus 1.75 is what y equals. So there's our equation. Okay. Now to find where it crosses again, we will put those, our original equation and the tangent equation in to the graph and see where they intersect. Okay, so here's our two equations. And it's really kind of nice to do this because then we can also check to make sure that we got the correct equation for the tangent line. So you can tell it just hits right there. There's our tangent, and it's going to intersect down there somewhere, but we can't see it. So two things you can do from here. You can actually just find it. You can find this intersection point without actually seeing the intersection point, but it's a little bit more satisfying to see it. So it looks like it's going to be pretty far down here. So I'm going to change my window. I need to see farther down, so my y minimum, I'm going to, just to make sure, I'm going to do negative 30 instead of negative 10. And then let's see what happens, see if we can see it better now. Because we don't really need to see this part up here. We want to see this intersection piece down here. Oh, good, there it is. So now we just got to find that intersection. So second trace, which is calculate, and we're going to find 5, the intersection. And then the intersection of the first curve. Let's see, let's get this over here closer to the intersection point that we want. Here we go. It's getting pretty close. There we go. And then we push enter basically 3 times, and it'll tell us the intersection point. Negative 3, negative 22 is the other intersection point there. So that's part I I, and this up here is the first part. Okay? And next one we're going to take a look at is number 10. Find where the tangent to the curve, this here at the point where x equals 1 meets the curve again. So pretty similar to what we just did in 9. So let's see, we need to find the equation of the tangent. So we need x1, y1, and slope. Okay, we know x1 is -1. To find y1, we can plug the -1 in. So y equals negative times -1 cubed plus 2 times -1 squared plus 1. -1 to the third power is -1 times another negative is +1. -1 squared is 1 times 2 is 2 plus 1, so we get y equals 4. Okay, and then the slope, got to find the derivative. So y prime equals 3 times -1 is -3. X squared, 2 times 2 is 4. And then that's going to be x to the first, and then the derivative of the constant is 0. So there's our derivative function. And now that we want that -1 to go in for both of these x's to figure out what our slope is going to be. So -3 times -1 squared plus 4 times -1. -1 squared is +1 times -3 is -3. 4 times -1 is -4. So our slope on this thing is going to be -7. Okay, so there's our -7. And now we just plug it into the point slope formula, right? Which is y minus y1 equals m times x minus x1. So we get y minus 4 equals -7 times x minus -1. Okay, that turns into a positive, so y minus 4 equals -7 times x is -7x. -7 times +1 is -7. Add 4 to both sides, and we get y equals -7x minus 3. There's the equation of the tangent. So to find where it meets the curve again, we are simply going to enter in to the y equals the original equation and our tangent equation. Okay? So here's our two functions. We'll push graph. And here is our graph. There's our first intersection point. So it looks like we got our tangent right. And there's our second intersection point. It's right down there at the very bottom. But I'm feeling good enough about it that we'll be able to find it. So let's do second trace and look for intersect. Oops, went down too far. Enter. And then if we do it without moving it there, it's going to give us this intersection point up here, which we already know. So we don't want that. We want to know the next spot. So we'll do enter, 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 and it should give us this spot right down here, which is at 4, -31. And really that's all they're asking on this one is just where does it meet again. So it meets again at 4, -31. Okay, let's look at next one here, 11C. Find the point where the tangent to this line at -2, 0 meets the line y equals 2x minus 3. So the point where the tangent, so we got to actually find the tangent of this here. So we got x1. We know that x1 is -2. We actually they give us the y1 also. Y is 0. So all we got to do is find the slope. So to find the slope, we got to do the derivative, right? Y equals 2 over x plus 1. Want to move that x up first. So it's y equals 2x to the -1st plus 1. Now let's do the derivative. -1 times 2 is -2. We subtract 1 from that, so that's x to the -2nd. Derivative of constant is 0. So there's our derivative function. So then we simply want to plug -2 in for x here. So y prime, or our slope, is going to equal -2 times -2 to the -2nd. Okay, that's a bit. That's a lot of -2's there. So you could plug that in your calculator, or you could also, like I like to do this. I like to turn this -2 over x times x to the -2nd over turns into x to the 2nd. So then this would be -2 over -2 squared. Negative 2 squared is 4, so this is just going to equal negative 1/2 for our slope. Let's do 0.5. So then that means that our tangent line is going to be y equals, point slope formula, y minus 0, y1, equals m, which is negative 0.5, times x minus negative 2. So we get y equals negative 0.5 times x is negative 0.5x, and then negative times 2 is negative 1. There's one equation, and there's the other equation, and we're going to simply put those two lines in and find out where they intersect. So we'll go into the y equals and put those in. So there's our two equations. Graph that. Of course, I had zoomed in from before, so it's going to look a little funny here, but it still works. Just for my satisfaction, I'm going to go back to zoom standard. Just looks a little nicer that way. And there's the first line, and then our red line is going to be this 2x minus 3, and we're just going to find that intersection point right there. So second trace, and we're going to find the intersection, and that's pretty close to the intersection point already, so enter, 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 and it gives us our intersection point is 0.8 and negative 1.4. And there's our intersection point. Okay? Alright, one last one. Consider the function f of x equals x to the fourth, blah, 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 blah. Find the equation of the line which is tangent to the curve at the point where x equals 1. So, for part A, we're going to need x1, y1, and slope, right? We know that our x1 is 1. So to find y1, let's plug that in. So f of 1 equals 1 to the fourth minus 2 times 1 squared plus 2 times 1 plus 3. So that is 1. 1 squared is 1 times negative 2 is minus 2 plus 2 plus 3. So that gives us 4, right? So our y is going to be 4. And then to find our slope, we've got to find our derivative, right? So f prime of x is going to equal 4 times x is 4x. Subtract 1, and that's x cubed. 2 times negative 2 is negative 4. X to the 2 minus 1 is 1. That's how x to the first. 1 times 2 is 2. And we subtract the 1, and that turns into 1. That gets rid of the x's, and then the derivative of constant is 0. So there's our derivative function. So to find our slope, when x is 1, we plug 1 into these two x's here, right? So 4 times 1 cubed minus 4 times 1 plus 2. And really, we could put f prime of 1, meaning the slope at 1. But anyway, so this is going to equal 1 cubed is 1 times 4 is 4. 4 times negative 4 times 1 is negative 4 plus 2. So our slope on this thing is going to equal 2. So our equation to the line, let's see, let's just keep working this way. We got y minus y1 equals m times x minus x1, right? So y minus 4 equals 2 times x minus 1. Distribute our 2 through, and we get 2x minus 2. Add 4 to both sides, and we get y equals 2x plus 2. Okay, so there's the equation of the line which is tangent to the curve at x equals 1. So there's our tangent, and they say find the point at which the tangent meets the curve again. So that's where we're going to plug both of these functions into our y equals and graph, see where they intersect a second time. Okay, and here's our two functions. Let's see if we can see what's going on here. So there's our x to the fourth function, and then our derivative 2x plus 2. There we go. Look, it's actually, it looks like it's the tangent at two different points there, right? At 1, and also looks like it might be at like negative, maybe negative 1. So that we can actually find out for sure. Second trace, which is calculate. Number 5 is the intersection. Let's get over here closer to that point. I always like to put it not right on top of the point so I can actually see the cursor move. So enter, 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 and we get, oh, apparently I didn't hit the last enter. Either that or it's frozen. There we go. -1, and then it's y is 2 point blah, 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 e to the -8. That means that this is 0, so it's -1. So it runs back in at -1, 0. So that's part B. Okay? All right. That's all we have for 11A Part 2. If you have any further questions, please feel free to ask. Thanks.